Greetings, sir. My name is Brownlee Willie Sanengwe. My student number is 2896653. I'm a student of University of South Africa. I'm doing transportation and pavement geometric design. I'm upgrading a road of Dundee West, and now drive M to a 39 from a 2-lane road to a 4-lane. And my project is located in Acacia, City of Tshwane, a municipality located in Gauteng. And my alignment is found in the west side near the Clarina and east side near the Wilma. And the function class is U3, which is urban minor artery TPG3700 The scope is to transition from the 2-lane to a 4-lane. And the length was found to be, the length that I'm working with in my design is 4.785 kilometers, and my design speed is 80 kilometers per hour. So my project location, this is the coordinate that was obtained from the geometric data and from the data that was surveyed, and also the route runs from southwest to the northeast through the Pretoria North and passes through the local Acacia Department of Home Affairs. And so we can also verify that by the Google Earth Pro map that is shown by our right. So my existing road and the motivation of this upgrade is that this road has cracks. It has cracks, and that is one reason for motivation. And the other reason is there is urbanization, a lot of urbanization. The crowd beneath the crowd, the crowd that is this road is supplying, like the crowd that this road is connected to, the town Acacia that this road is connected to, it has a lot of urban sprawl, and that causes a lot of population and a lot of cars to use this road for transportation and even heavy vehicles. So this puts a lot of effort on the road, and it's prone to cracking for the road, and also it can also conflict with head on head collision, because it's just a 2-lane road and it has a lot of curve, and also has a curve that is even above 70 degree for the curve. So the reason is that this road has it's oversaving. It's not that the road is too bad, but the road is oversaving its purposes. So we need to upgrade the road so that it can fit with the traffic that is being used by the road. So the intended design, I said I'll work with 80 kilometers per hour for my design speed and 2% cross fall, and I'm intended to do a 4-lane to save the population so that no collision or a cracking or overuse of the road can happen. And also my width that I'll adopt is 17 meters, and these are the governing standard TRA 26, TRA 817, TRA 4 for structural design and flexibility. And my cross section, it's to adopt 3.5 meters for the carriageway, so a single carriageway, and it's a double carriageway, so that means in one way it's 7 meters and 1 meters for the shoulder and 2 meters for the sidewalk, and all of it has a 2% crossfall. And also my climate, it has a maximum of 29 degrees, which is ranges from 30 to 32 from November to February, and also an annual minimum of 5 degrees Celsius ranges from 3 to 6 in July, and rainfall is 700 to 800 per year, and a strongly seasonal summer thunderstorm. And also my wind is found, this is Gauteng province, is found it's moderate and is found within 2 to 5. And my traffic estimate and the subgrade CBR, my baseline for 2026 gives me 250 E80s per day per direction, and my growth at 3% for 2 years in construction and 4% per year for 20 years in design life. And also the opening traffic starts from 265.25 E80s per direction, and the cumulative design traffic is approximately 2.85 E80s, and this classification falls under TRO HF4 for ES10. And the 42 point for the center line CBR was carried out. A statistical sample mean shows 6.6 and standard deviation 1.8, and also a CBR shows a 90% reliability. and the classification falls under the sub TRH table 16 subgrade class HD3 from 3 to 7% as shown here. And also my horizontal alignment, these are the control points that was obtained from the surveys and the field data, my chainage point and my easting point with my northing point. So I adopt, like I said, I adopt a radius of 300 meters. And also these are the points and the manual checks and the governing curve. So the Department of Home Affairs has the highest deflection. So this will be taken and also be worked against the standards. So this is the tangent, my information that I used to calculate my checks, and I have a curve length of 369 and my external distance of 67 and the assumed radius. So I'll check if this assume is well within the standard. Also this is my BC chainage and my PI chainage and my EC chainage, all were obtained from the coordinate. And also TR7 adequacy check, it shows that my minimum, my F max, which is 0.14, the maximum 0.14 super elevation is at 80 kilometers per hour, and my radius minimum radius shows to be 252, which my assumed 300 radius is where we're above 252, so it's adequate. And so the demand for my super elevation is 0.16 for F, and the applied super elevation is 4%, which gives a required of 0.125, which is lesser than lesser or equals to 0.1 which is okay. 0.128. So my margin, it gives me only 0.1 to 0.0112, which is the assumed curve, which is way okay. But if I use my coordinate points, it gives me this direct coordinate point, not assume my radius for my coordinate points, and I use it for the chainage and everything. I'll calculate the radius and give me this, and it gives me a approximate margin 6 times better than the radius that I assume. So I did an Excel verification. It shows everything and every check was okay. Everything and every check was okay. So this can be adopted or this can be adopted. And also my vertical alignment and my typical cross section. My vertical alignment, my cross 4 is within 14.3 meters over 4.94 kilometers, and my cribs key is above 25 and sax is above 35 for 120 SSD, which is stoppage distance at 20 kilometers, 80 kilometers per hour. So like I said, it's a 2 carriageway, and all each one has 3.5. So also is 1 for each lane, for each side, because I'm designing a 4 lane. So the one side has a 2 carriageway and has a survey shoulder 1 meter, and the sidewalk 2 meters, has a 2% cross 4 with a cut slope 1:1.5 and fee slope 1:2. Also my design standard and subgrade determination, I used my standard which I applied is TRS 4 for structural design procedure, TMH1 material testing and classification, COTO material and construction specification, and TRS 14 for local material and source suitability. And my subgrade design outcome shows my CBRO to be 4.22, which is classifies under SG3 TRH4 table 16, and my upper selected layer is 150 G7, and lower layer is selected as 150 G9, and in situ subgrade rip and recompact to 150 G10. So my pavement alternative, I have alternative A, B, and C. Alternative A granular mix, and my region is moderate, and B cemented, C hot mix. So this has a width of 690 and has a width of 780 and has a width of 710. So this is it. So this can be the best option because we already have an existing road. Before they construct the existing road, it was already that existing road they compacted it, and that road we don't have to dig that much because cars have been passing also, and has been compacted over time. Also, my choosing alternative and my justification for it is that a category B presents a favorable granular base and cemented grace over cemented base. So basically, it's like alternative B is most prompt to reflection of shrinkage cracking. Like alternative B is more prompt to cracking. So we don't need cracking because that's one thing we are fighting against. So also a thin layer structure of 690 can be the best because we already have a corridor or that is compacted, and a granular base is the easiest to recompact and to reopen and reinstate for many services changes along the urban corridor. So these are the layers for the granular base for my alternative that is selected and has a width of 690 mm. And also my design drainage conceptual design, my humid subtropical dry winter and wet season, which occurs from October to March. It's short intense convective storm, and a minor system catchment. It's well within the threshold, and also my TC is 15 minutes. And also catchment is being found, the area for the catchment, the 1.875 hectares, and also my flow. And my design intensity give me 65 mm per hours, and runoff coefficient gives me my 0.8. And the coverage that was adopted was 450, so for the reinforced concrete pipe. So the drainage facilities, these are the drainage, and these are the facilities where it is being located. So these are the facilities is being located, and the start of the project the side drains, and the end of the project the side drains. And the primary culvert witness the bend, low point is 450 mm reinforced concrete pipe. And my software that I used for this geometrical design, I incorporated a standard for TR7, TRH26, TRH4, and Sanra geometric and drainage manual. Sans 1200, and the coordinate system is HATE bested 94 / LO29, and it has a 300 plus. It's not only 300 plus a GPS topographic survey, and imported using PANS in my Civil 3D. And the reason why I used Civil 3D is because it is able to create you that thin layer, of existing ground, and also alignment. It's able to give you that alignment of the profile and the corridor modeling, and also it can automatically give you the mass haul and the volume reporting. So it's a very nice, it's very nice to use it, and it's very easy. So this is my workflow. I started with my importing my data, and also creating my corridors, and also extracting my quantity takeoff. And the alignment was built from the surveyed center line curve matches the 300 or is 400, because I inputted 300 because I wanted to get something closer to the minimum to see if the design is going to be okay. So this 465, I can also use 465 is way above the minimum. Corridor assembly from the 3.5, so my corridor is 3.5 and 1 meter shoulder, 2 meter side work, and all of it was using a 2% cross for the sample line, and the quantity carries criteria set up the drive and the cross-sectional sheet airport. So my head work, this gives me the 125,472 meters square for the corridor, and have a cut volume of 48,776 and a fill of 13,031 and a net of 35. So this is what I need to take away, and these are my supporting drawings that were added to my report. And the summary of my report is just simple, because I use a 6 curve which is checked against the TRA17, and also my alternative A that I was choosing has a thickness of 690, and the reason is because I want to avoid crack and also constructability grounds, to see how the material can be sourced and easily supplied in the site, and the job get done. And the drainage method design, I used a 450 mm culvert, and also Civil 3D was used for modeling the corridor. The drawing set the earthwork report to generate from the ray survey data. So the earthwork was found to be this, as said before, that is required to be take off. Thank you very much. And I use my student number to get my license. Thank you very much for reviewing this. I hope you have a great time also looking at this report. I really put what I have to put in it, and I believe I've done what I have to do. And yes, thank you.